Over the last few years, social networks have grown at an explosive rate. The amount of content contained within these networks is massive, and in its current state, it is nearly impossible to make sense of it all. Our goal in creating TwitterFlock was to establish a means to visualize and navigate the explicit and implicit links created within these networks. TwitterFlock explores what we call implicit networks in an effort to improve understanding of the interactions and relationships these networks present. While explicit networks rely on friends lists, bibliographies, and other such clearly denoted data relationships, implicit networks must be derived from hidden and indirect relationships, such as the activities of members in a social network.
We chose to focus our analysis on Twitter, a microblogging service that allows users to post status updates of 140 characters or less. The interactive visualization that we have developed, based on the classic Boyd's flocking simulation by Craig Reynolds, represents individual status updates, or tweets, as birds which will form flocks based on their computed relationships. By bringing directly connected tweets into closer proximity, indirect relationships become clearly evident without the combinatorial explosion that will result from attempting to calculate these relationships directly.
In the background, TwitterFlock accesses a large database of over 1 million tweets pulled from Twitter's streaming API. Users can then use any set of search terms to filter these results pulled from the database. Then select and manipulate tweets to explore the connections between them. First, we are going to show the results of a search for Google on Twitter.com. So, you can see the results here, and there are quite a few of them. We can just keep going and going and going. Now we're going to show you the same search, but in TwitterFlock. You can see here how the groups are starting to form. The flocks are created by looking at the textual relationships between the tweets. If the relationship is high enough, the tweets will move closer together, eventually forming distinct flocks. Now we're going to pause the simulation and show you how these tweets are actually related. We're going to look at this group first, which is about Google Wave, as you can see here in our Twitter display. This one here is talking about Google Voice invites. The next one is just about Google Voice, which is why only the right two are related. The group above it is about Google Buzz. As you can see, all three mention Buzz. Starting the simulation again, we can see a few more features. We can drag tweets around, and the ones connected to it will start to follow behind it. Tweets continue to flock together during the simulation. If we grab this Android group, they will follow behind it. And some of these have intergroup connections, while part of the group has no other internal connections.
We performed a series of user studies to determine the effectiveness of our visualization. Initially, the strength of the relationships between two tweets was used to adjust to how strongly they would be pulled towards each other. The user studies indicated the resulting subtlety in the formation of flocks simply obscured the information we were presenting. Because of this insight, we decided to represent links between tweets as a binary decision of yes, these tweets are related, or no, they are not related. The clarity of the resulting visualization encourages informative exploration in a fluid, intuitive manner.
As the use of social networks grows, it becomes increasingly difficult to comprehend and browse those networks. The visualization we have developed allows for depth in both presentation and user interaction. This simulation, while constructed specifically to map activity in Twitter, is robust enough to be extended to other data sources, both inside and outside the realm of social networking.